For the day 2 notes, this is on linear and nonlinear functions. So let's define what linear and nonlinear are. So for a linear function, a function whose graph is a non-vertical line or part of a non-vertical line. For the nonlinear function, a function whose graph is not a line or part of a line. So looking at a couple examples of this. Part A is going to be nonlinear. We can see it's not part of a line, it's not a line, it's definitely a kind of a curved shape. In part B, we have a line. It's a straight line. It is not vertical. Vertical will be up and down. Okay? It is just slanted slightly. So this is linear. In the bottom 2 examples, C and D, it says, how do you determine if a function is linear or nonlinear from a table of values? So 1, you could graph it. In this case, we don't have a graph to graph it. We could make our own graph if we wanted to. But once you get up to like 312, that's quite a bigger number that you don't really want to mess with if you don't have to. So how else could you figure this out? Well, it says make sure your input and output values have a common difference. So as I can see in the x's, we're increasing by 1 each time, right? And then on the y values, do we have a similar pattern known as a common difference? So from 3 to 5, this is an increase of 2. From 5 to 8, we have an increase of 3. And from 8 to 12, we have an increase of 4. So this right here, they're not common, meaning the same number. So since they are not common, we would say this is nonlinear. In part D, we check our x values. So we're increasing by 1, increasing by 1, increasing by 1. Okay, that's good. Here, from 8 to 10, I increase by 2. From 10 to 12, I increase by 2. And from 12 to 14, I increase by 2. So here, this is a common difference. Okay? And so this would be linear. Okay, in example 2, I want to take the ordered pairs and put it into the table here. So I just transfer them. So 0, 2, 1, 3, 2, 4, 3, 5, and then lastly 4, 6. So I'm going to graph it. So 0, 2, 1, 3, 2, 4, 3, 5, and 4, 6. And here I see that this would be a straight line. So this is definitely linear. If we had like a U shape or some kind of a curve, we would go with nonlinear. For example 3, it says identify the independent and the dependent variables. For the table, identify your independent and your dependent. So the first one here would be your independent, which is N. Your second one would be the dependent, which is C. So your independent acts as like your x value or your x-axis, so that would be down here. Your dependent acts as your y-axis, and we would label that C. Now we would have to label the grid lines down here. So it looks like we have 0, 1, 2, 3. It's just counting by ones. So the intersection here, the corner, that's 0, 1, 2, and 3. Then we have to go from 18 to 27 over here on this one. Obviously, we're going to have to skip some numbers in order to fit all of this on the graph. So I did this, and I had, starting at 16, and I counted by 2. So I said, okay, 16, 18, 20, 22, 24, 26, 28, and I ended at 30. So it says if you have 0, purchased. This doesn't make a whole lot of sense. You have $18. So 0 at 18. 1 purchase you have at 21. So here's 20. 21 is going to be halfway between 20 and 22. At 2, we're going to 24. And at 3, we go to 27. So again, it's going to be halfway between 26 and 27. It also wants us to state our independent and our dependent variables here. So we said our independent variable was the letter N, and our dependent variable was letter C. And we have them defined here what those mean. Okay, and then for the last page, we have to sketch graphs. So it says Shelley walked up a hill, stopped to have lunch for about an hour, and then continued up the hill. Sketch a graph to represent her elevation versus time. So on the side, we're going to say that's your elevation, and time at the bottom. And this is a sketch, so we're not making it perfect. We're just going to make sure we label the axis, which we did, and then we just sketch. So if Shelley is walking up a hill, we start down here at the origin, and we just graph up the hill. She stops to have lunch for about a half an hour. So when you're showing something where you're just stopping or being still, or you're taking a break from moving around, then it's just a flat line. Then she continues up the hill. So that's her continuing up the hill. For part B, Chris is at the top of a mountain. So if he's at the top of the mountain, we're going to start up here. He hikes down the mountain. He stops for 2 hours, so quite a bit of time he stops to take a break, and then he returns to the top of the mountain. So we're going back up. Okay? Again, this is elevation versus time. In part C, it says Sharon left her house. So we're back down here. She left her house and rode her bike quickly to Sally's to visit. Okay, now usually when you draw a line like from her going from one place to another and it says quickly, your line is a little steeper. So we might want to draw that a little steeper because quickly means faster. She stayed at Sally's for about 45 minutes. So she stopped there, she visited, and then she slowly rode home. So slowly means that she's still going home but at a slower rate. And so that line becomes less steep. Okay, so quickly, not as quickly. And then lastly, a cyclist rides for 2 hours traveling at a constant speed. Okay, so this is the constant speed. He stops for 30 minutes, very short amount of time, and then he continues to ride faster at a faster pace. So instead of having this just kind of casual ride, he now is going a little bit quicker. So we're going to make it a little bit steeper. Okay, not quite vertical, but just a little bit steeper. Okay, now for the last two, C and D, it says that we're sketching the graph to represent distance versus time in both of these. So time will be your x-axis, and the distance will be your y.